Today, I will talk about researching cultural heritage using GNSS and GIS. The contents of today's lecture are shown here. 1. The goal of this lecture. 2. Brief self-introduction. 3. What can we do with GNSS and GIS? 4. How to use GNSS. 5. How to use GIS. I will talk about items 1 to 3 in this lecture and items 4 and 5 in the next lecture. GNSS and GIS are important and powerful tools for the management, research, exhibition, and education of cultural heritage. By confirming the exact locations of archaeological sites using GPS data and the creation of maps, we can use it not only to manage archaeological sites and organize survey information, but also for exhibitions and educational projects at museums. In this lecture, we will focus on what is most useful to you, making the most of our limited time, so you can learn the basic practical skills of GNSS and GIS. I am Hiroshi Yamaguchi from the NNRICP. I'm a researcher in the Archaeological Operations Unit of this institute. I specialize in archaeology, mainly in the research, development, and popularization of archaeological sites and research methodology. Including Japan, I have so far researched archaeological sites in Russia, Mongolia, Uzbekistan, Indonesia, and India. The Nara National Research Institute for Cultural Properties, abbreviated to NNRICP, is an institute for the comprehensive research of cultural properties. The NNRICP works every day on the excavation, research, conservation, and presentation of historical remains and cultural properties. This here is a chart showing the organization structure of our research institute. The section I am in is the Archaeological Research Methodology section, which is a part of archaeological operations. At the Archaeological Research Methodology section, we handle the research of archaeological sites, their survey methods, and the development and application of research technology for cultural properties. We are also seeking to promote the spread of research technology and methods for cultural properties. Recently, we have focused our efforts on the digital recording of archaeological sites, structural remains, and artifacts, as well as archaeological prospection. Let me introduce a part of our research. On the left are recent research efforts involving the use of a laser measuring device called LiDAR to quickly measure the topography of archaeological sites. On the right is SFM-MVS, a technology that can take 3D records with only a camera, a PC, and software without using a specialized device. This is a picture from an archaeological prospection. This method can check the conditions under the ground without destroying archaeological sites. Underground surveys using GPR, or ground penetrating radar, is a method of surveying underground conditions non-destructively. In addition, most of the recording methods of cultural properties described so far can be adopted by many research institutes and individuals. Here, at the NNRICP, we hold workshops regarding record keeping for local government staff in charge of cultural properties across Japan. Workshops are not only held in Japan, but also overseas to share research methods with other countries. The slide shows a workshop held in Mongolia. These are participants in the workshop held in August 2018 at the National Museum in Indonesia. Of course, we are also conducting research using GNSS and GIS. The image shows the locations of scattered cultural heritage sites on a map representing geographical features on GIS. We recorded the locations with a handheld GNSS, walking on an ancient Japanese road. I started this kind of research in 2001. Now let's take a quick look at what we can do with GNSS and GIS. What is GNSS? GNSS, Global Navigation Satellite System, is a generic term for satellite positioning systems such as GPS, GLONASS, Galileo, and Quasi-Zenith Satellite Systems, QZSS. For example, GPS, Global Positioning System, is a system developed by the United States for navigation support for aircraft and ships. This system consists of GPS satellites, with 30 satellites arranged in 6 orbital planes, orbiting at a height of about 20,000 kilometers, with control stations that track and control GPS satellites and uses receivers for positioning. This system uses GNSS satellites orbiting at a height of about 20,000 kilometers to determine our positions by simultaneously knowing the distances from 4 or more satellites. The Garmin GPS Map 64 is a device that receives information from this GNSS and gets its current location. Its positional accuracy is about 5 to 15 meters in radius. The Garmin GPS Map 64 is a rugged, full-featured handheld GNSS device with GPS and GLONASS combined. This device features a 2.6-inch sunlight-readable color screen, a high-sensitivity GPS and GLONASS antenna, 4 gig internal memory, and a micro SD card slot. By using this device, it is relatively easy to obtain location information even in the forest, and it is resistant to falls and impacts. It is one of the pieces of equipment often used in cultural heritage fieldwork. I am using one similar to it. This device allows you to 1. Record your current position. 2. Record the track of your movement. 3. Confirm the current position on a map. 4. Confirm the location of the recorded point on the map. 5. Confirm the recorded track on the map. For 3 to 5, however, the map must be loaded on the device. Next, what is GIS? GIS, Geographic Information System, is a technology that comprehensively manages, processes, and visually displays data, particularly spatial data, with information on location, using the geographical location as a guide. It enables you to make advanced analysis and allow for rapid decision-making. The image on the right is the screen of QGIS, one of the programs that run GIS. In the survey, management, conservation, protection and utilization of cultural heritage, GIS is operated together with information on the location of cultural heritage and the surrounding environment, such as rivers, topography, or land development due to deforestation and urbanization. With this mechanism, we can manage, analyse, and visualise what cultural heritage is where and how it is located. Using GIS, for example, you can overlay the distribution of cultural heritage sites with an old map like this. You can also overlay the distribution on topographical features in this way. Of course, if you have satellite images, you can overlay them too. In this way, GIS is a system that stores and analyzes a variety of location-based information and can overlay and display the information in geographical space. By the way, this map shows the slope of the terrain and the locations of cultural heritage. This is the end of the first half of the lecture. In the second half of the lecture, I will talk about how to use GNSS and GIS. In the first half of the lecture, I talked about the goals of this lecture and what we can do with GNSS and GIS. In this second lecture, I will talk about how to use GNSS and GIS. First, let me talk about how to use GNSS. I will briefly explain how to use the handheld GNSS, Garmin GPS Map 64. I will call this GPS Map 64 from now on. The handheld GNSS I use at this time is GPS Map 64S. This is the Japanese version of GPS Map 64, which you are using. The color is different, but the functions are almost the same. You can check the detailed manual of GPS Map 64 at the URL in this red frame. I will explain the basic operations most necessary for investigating cultural heritage using this material. There are also videos in the material that explain how to use GPS Map 64. You can view the videos at the URL shown in the red frame. About the GPS map device overview. 1 is the GPS GNSS antenna. 2 is keys. 3 is the power key. 4 is the mini USB port. 5 is the MCX connector for the GPS antenna. 6 is the micro SD card slot. 7 is the battery compartment. 8 is the mounting spine. 9 is the battery covered D-ring. Of these, 2, 3, and 4 are the buttons that are most frequently used. Let me explain each key and its functions. Select Find to open the search menu. Select Mark to save your current location as a waypoint. Select Quit to cancel or return to the previous menu or page, and/or to scroll through the main pages. Select Enter to select options and acknowledge messages. Select Menu to open the options menu for the page that is currently open. Select Menu twice to open the main menu from any page. Select Page to scroll through the main pages. Select direction cursors to select menu options and move the map cursor. Select In to zoom in on the map. Select Out to zoom out of the map. Set the position format. Please note that you should not change the position format or the map datum coordinate system unless you are using a map or chart that specifies a different position format. select Setup, and next, select Position Format. Set the position format in which a location reading appears. Select the first column and press Done to change it to HDDD.DD degrees. This format is easy to use and can be read directly into your GIS. Acquire satellite signals. It may take 30 to 60 seconds to acquire satellite signals. Go outdoors to an open area. If necessary, turn on the device. Wait while the device searches for satellites. To check the strength of the satellite signal, press Menu twice to select Satellite, and press Done to change the screen. The GPS symbol flashes while the device determines your location. The GPS signal status bar shows the satellite signal strength. Make sure the satellite signal strength is sufficiently high when pressing the Mark key to save your current location as a waypoint. Create a waypoint to record the location of cultural heritage. You can save your current location as a waypoint. First, select Mark. If necessary, select a field to make changes to the waypoint. Select Done. Press Mark. The screen changes to the one like this image. From top to bottom, they indicate 1. Name of the waypoint. 2. Memo. 3. Position. 4. Altitude. You can enter a few alphanumeric characters in the box for 1. It may be possible to enter the name of a cultural heritage site or a place, but the number of characters allowed is limited. So, you are recommended to leave the default number in place and write a note in your field notebook or somewhere else so that the number corresponds to the name of the location. When you're done filling out the form, press the arrow to select Done. Now, your current location is recorded as a waypoint. When you select Map on the left side of Done, you can show the current location on the map if the map is stored on the device. GPS Map 64 also allows you to keep track of your movement, which is called track log recording. It is useful for recording roads and so on. I will skip this for the sake of time, but please refer to the videos. Now, next is GIS. Of the GIS, let's use QGIS, a free and open source program to display the data collected by GPS Map 64 on a map. QGIS is a free and open source geographic information system. QGIS is a system that is free to use and open to the public as to how it works. It has many users and is used all over the world. You can find the latest version of the QGIS manual and the stable version of the manual at these URLs, respectively. Now, press the Windows key, type QGIS, and select QGIS Desktop 3.14.16 with GRAS 7.8.3 to start QGIS. Click on the cross in the upper right corner of GRAS Tools to close the window. Click on the white paper icon in the upper left corner of the screen, circled in red, to start a new project. The QGIS screen consists of 5 components. They are 1. Menu bar, 2. Toolbars, 3. Panels, 4. Map view, and 5. Status bar. Set the coordinate system to the one that corresponds to Bhutan. Many countries and regions have their own national land coordinate systems. In Bhutan, the national land coordinate system is set as DRUCREF 03/Bhutan National Grid. In Bhutan, the national land coordinate is set as DRUCREF 03, for which the code is 5266. So, if you want to use it in GIS, you need to set the coordinate system to 5266 first. To do so, click on the EPSG button in the red frame at the bottom right of the screen. On the displayed screen, enter the coordinate system of 5266 defined by Bhutan in the Filter field. Next, select DRUCREF 03 displayed in the bottom column and click on Apply, and next click OK. Load ASTA GDEM, Advanced Spaceborne Thermal Emission and Reflection Radiometer Global Digital Elevation Model. First, select the browser column marked 1. Find the downloaded folder with Bhutan_GDEM_grid and double-click on this file to load the data into QGIS. Then, the loaded Bhutan_GDEM_grid is displayed in the column marked 2. This Bhutan_GDEM_grid is the dataset that show the altitude of the entire Kingdom of Bhutan. This dataset is called ASTA GDEM, downloaded from earthdata.nasa.gov and processed in QGIS. Next, click on GADM36_BTN_GPKG to load a map showing Bhutan's administrative boundaries into QGIS. These data were extracted from the GADM database at www.gadm.org, version 3.4, on April 2018. They can be used for non-commercial purposes only. It is not allowed to redistribute these data or use them for commercial purposes without prior consent. See the website www.gadm.org for more information. Click on the floppy disk icon circled in red to save the project. Decide on the location to save the file, as well as the file name, and press Save. The project has been saved. Change the properties of the layer. Right-click on GADM36_BTN_2 and select Properties to change the way the layer is displayed. Click on Symbology in the left column to change how the administrative boundaries are displayed. Click on the red frame and select Simple Line to change it. You can change this color and thickness to any color later. Change the shade of Bhutan_GDEM_grid as well. Right-click on the target layer to open its properties. Then, change in the following order. 1. Change render type to single band pseudo color. 2. Click Classify. 3. Set the blending mode to multiply. You have now changed the shade of the map. Double-click on Bhutan_hillshade to load it and to make the shading of the terrain clearer. Next, drag Bhutan_hillshade to the bottom of the layer. Now, let's load the data required with GPS Map 64 into QGIS. QGIS can use a built-in program called GPS Babel to acquire data directly from a GNSS device and create a new vector map layer. Let's connect the GNSS device and the PC with a mini USB cable. Click on Vector and next click on GPS Tools on the menu screen. Click on the 3 dots in the red frame. Open the location of the waypoint you want to import. Specify the file and click Open. This shows the result of importing the data from GPS Map 64. To see the attribute data, right-click on the desired layer and select Open Attribute Table, as shown in the figure. This is the attribute data of the loaded data. When you record a waypoint with GPS Map 64, if you write a memo in the comment field, it will be shown here. Of course, you can also edit it later on your computer. The second half of this lecture is concluded here. Next is a demonstration based on the 2 lectures so far. Let's actually create an archaeological site map from GPS data while watching my demonstration.